Good day. You've just seen a sheet that did one example showing how you go from a formula equation to a complete ionic equation to a net ionic equation. And we're doing 5 more examples. Now some of these reactions will be double replacement or neutralization, and some may be single replacement. That's what we often run into. Anytime you see a gas, liquid, or solid, you love it in the formula equation. It stays exactly the same. You don't have to split it up. Anytime you see something that's aqueous and ionic, then it will split up. Now we have things that are aqueous and covalent. We call those molecular. And those things would not split up. So it's got to be both aqueous and ionic. So it says for double replacement reaction, if you form one precipitate, then that is the formation of that precipitate is going to create your net ion equation. If it forms 2 precipitates, then the net ionic equation will be exactly the same as the full ionic equation. And you have to write it out. But let's say you mix 2 compounds and you don't get any precipitate. So you got to write out all these dissociations, all the aqueous, but there's no net ionic equation because nothing changed. So let's try it. Now, you're going to say, hey, am I going to write these out? And the answer is no. Generally, if I write things out, it's very hard for you to read them. So I tried typing them out. Hopefully it's big enough you can see. Here we start off with our balanced chemical equation. And we see aqueous, aqueous, solid, and aqueous. We have to split this up, make sure it's balanced. Split it up, make sure it's balanced. Split it up, make sure it's balanced. Solid. That comes down exactly the same as it is in the formula equation. So sometimes you're going to need a little bit more room. It may take more than one line to write this all out. So 3 times 2 is why we have 6 sodium pluses. We have 3 carbonates here, and you'll notice 3 times 2 minus and 6 plus, those charges balance. Here we have 2 aluminums, 3 plus, 2 times 3, 6 bromides, and I made a jumbo minus sign there. This beast is solid. It comes down exactly the same. Then I have my 6 sodiums and my 6 bromides with our impressive charge there, so you can see it. Notice everything has a state. You forget a charge. You have a wrong coefficient. You don't put in a state. It's wrong. That's not good. Now, I have 6 sodiums and 6 sodiums, so those are going to cancel out. I have 3 carbonates there, and now the carbonates are part of that compound. Same for the aluminum by itself, now part of the compound. So those things are going to be in my net ion equation. The bromides are unchanged, so I'm going to be canceling that out. So the net effect is I end up with my 2 aluminums plus 3 carbonates becomes Al2CO3 in brackets 3 times solid. Charges balance out 6 plus 6 minus, no charge on the left, no charge on the right. You might say, hey, can you put the carbonate ahead of the aluminum? Yes, you can. That's okay. But often I simply put the metal first because it's going to be first in the compound. Number 2, very similar example. Aqueous, aqueous, aqueous. Here's a solid. So we're going to split up the first 3 beasties, and that's going to come down the same. So dissociating properly, 1 copper 2 plus. I better have the 2 plus because I had 2 chlorides there. Now I have the 2 chlorides, aqueous, aqueous. Plum bum, Pb is 2 plus. I know that from the charge there, or the subscript there. 2 nitrates and the aqueous. This has to be Cu2 plus. There's my nitrate, and this comes down the same because it's solid. Now, what I see, I can cancel out Cu2 plus, Cu2 plus. If you cross these out, you have to do it with the faintest of lines because I have to be able to see this. You may even just want to underline the thing so you know you're getting rid of it. And when you look at nitrate, it is going to disappear, and you're going to be left with the 2 ions that make the precipitate. And there are the charges, there are the formulas, there are the states, done perfectly. Next beast, number 3. Now we're looking at a single replacement reaction. So we have 3 calcium solid, we have this ionic compound, another solid. Well, we know solids come down the same, and these characters are going to dissociate because they're aqueous and ionic. So came down the same, split up into its ions, it's balanced, 2 golds, 2 times 3, 6 nitrates. And here we have our 3 calciums, 3 times 2, 6 nitrates, and our 2 golds came down like so. Net ionic equation, well, we get rid of our nitrates, and we can't get rid of anything else. Ca here is different from Ca2+. Calcium, something you could feel, you can touch it readily, it's a metal. This disappears. It is dissolved. It is invisible when in solution. And gold, same thing. You can't see it when it's in solution, and now you'll have solid gold. You can kind of guess that gold 3 nitrate would be an expensive beastie. So we just bring that down, and we bring that down, bring this down, bring that down, and you will see our charge is balanced. No charge there, 6 plus there. 3 times 2, 6 plus there, no charge there. Our charges on left and right have to balance. We're going to plow on. We're going to see if we can do this all in one video. This one, we have the magnesium nitrate. I kind of jumped ahead. And the potassium chloride, potassium nitrate, magnesium chloride. And you see aqueous, aqueous, aqueous for all 4 of them. So that means they have to all dissociate. So we go boom, boom, split, boom, boom, split, balance, boom, boom, split and balance, boom, boom, split and balanced. But what we do like about this is all the things on the left are the same as on the right. So we get to write down no net ionic equation. One more example. Here is a crazy one. So this one happens to be balanced for you. And the only thing that can change is this beast and this beast. They're aqueous and ionic. The other 3 chemicals will stay the same. So that came down the same. That split and was balanced. That split and balanced. 3 coppers, 3 times 2. That's why we have the 6 nitrates there. And we have 2 NOs there, gas, and 4 H2O liquid. So you say, what can we cancel out here? Well, not a lot. We had 8 nitrates here. We had 6 nitrates here. So we go goodbye 6. 8 minus 6 is 2. We're going to end up with 2 nitrates on the left. And you can go through and actually check that this is balanced in terms of atoms and charge. I'll do the charge for you. 8 plus, 2 minus, this side is 6 plus. 3 times 2 plus is 6 plus. No charges, so we know the charge is balanced. All right, so hopefully you've had a chance to fill that all in. That covers a lot of terrain, and now you should just be off to the races with all the worksheets and questions about getting to net ionic equations.